just wanna hold you, girl. But you keep on running to his world. I don't know why you're still with him. He don't care about your existence.
Hi, this is Mr. Al-Araimy, and this time I've got a PowerPoint for you dealing with masses and equations. This one is called The Story of a Mastermind. So we'll start off with our storyline. An emperor was angry about corruption in his land. The last straw was when he had expected 60 grams of silver to be gained from 60 grams of silver oxide, at least even 55 grams. He was furious and he threw all his financial advisors in prison. One of them was a genius. His name was Marcus Aurelius Abacus. Abacus knew he had to get out of prison, so he had an idea. He would prove to the emperor that when masses were reacted, the masses were often converted into different products, and some were even left unreacted. This would be his ticket to freedom. So, what kind of questions do we get? Often, you get something like, what mass of hydrogen is produced when 192 grams of magnesium is reacted with hydrochloric acid? And you'd wonder, what does that mean and how to approach it? Well, let's break it down into 4 simple steps. So, I've got my question up there, and we've got these 4 simple steps. One of them is the first step is to write a balanced equation. Second one is to calculate the number of moles of the substance of what we're given using what we have. The third thing is to use ratios to find out the proportion of moles necessary. The fourth is to use the molecular mass to calculate the answer. And the final thing is we're going to use this formula triangle. This formula triangle is the only one we are going to need. Okay, so let's have a look at this first example and how we broke it. Okay, so here's our balanced equation. Magnesium plus 2HCl gives us magnesium chloride plus hydrogen. That is balanced. There's 1 magnesium there, 1 magnesium there, 2 hydrogens there, 2 hydrogens there, 2 chlorines there, 2 chlorines there. So that's a balanced equation. The second step is to calculate the number of moles of the substance using what we have. Now, the idea here, first of all, is to identify what it is we are actually looking for and identify what it is we've got in this, that we can put into this triangle so that we can actually use it. So we know for a formula triangle to work, we require 2 things. Now, we want to calculate the mass of hydrogen, but the only thing I can get for hydrogen so far is its molecular mass, which is 1 plus 1, which is 2. So, that doesn't help. The other thing I've got there is hydrochloric acid. That's kind of irrelevant to the question. And even still, with that, with the only thing I've got there is the molecular mass. What I do have here is magnesium. So, having a look at that, I have the mass of magnesium, and I also can get the molecular mass of magnesium as well. So, that fulfills us being able to use this formula triangle to calculate the number of moles. So step 2, calculate the number of moles of the substance using what we have. So we've got 192 grams of magnesium. We can put 192, which is the mass of magnesium, on the top, because we try and we cover up what we are trying to find. So if we cover up the number of moles, we know that it's mass divided by mR, molecular mass. If we wanted to find a molecular mass, we'd cover that up, and it'd be mass divided by number of moles. If we wanted to find out mass, we'd cover that up, and it would be number of moles multiplied by the molecular mass. So, going back to this, we have the number of moles of magnesium. We can calculate the number of moles of magnesium, and that's 192 divided by 24. We take 24 because 24, if you look it up on the periodic table, 24 is the relative atomic mass of magnesium. And when we do that, it gives us 8 moles. Now, the next step is to use ratios to find out the proportion of moles necessary. So let's have a look at what this is actually talking about. So, looking at this, if we can imagine these are molecules, one atom of magnesium reacting with 2 molecules of hydrochloric acid will give us 1 molecule of magnesium chloride and 1 molecule of hydrogen. So, in terms of looking at what the equation is actually saying, the equation is actually saying that I have 1 mole of magnesium. If you can see, there's a 2 in front of there, reacting with 2 moles of hydrochloric acid. So that's a 1 to 2 ratio. Will give us 1 mole of magnesium chloride and 1 mole of hydrogen. We can see, you can imagine there's an invisible 1 in front of each of these, but we don't need to write invisible. We don't need to write the 1 because it's there, it's written. So, using these ratios, we can find out the number of moles necessary. So what here are we trying to calculate? We're trying to calculate the mass of the hydrogen. We are told that we have 8 moles of magnesium. So I'm going to make that quite clear here. So we have 8 moles of magnesium. Now, we're told if we had 1 mole of magnesium, we'd need to react it with twice as many moles of hydrochloric acid for this reaction to proceed. So, if we're reacting 8 moles of magnesium, we must react it with twice as many, which would be 16 moles, which would give us 1 mole of magnesium, which would be 8 moles, and 1 mole of hydrogen, 8 moles. Essentially, what you've got here is a ratio. So where I could call it a 1-2 ratio, and then, I've got 1 here. I could do something like that. It will help you. It will help you get around this idea. So 1, 2, 1, 1. I could go around with that sort of idea. So if I know that I have 8 moles of this, this one, because it's got 2 in front of it, would be twice that, and this one here would have that invisible 1, so it's 8 moles, and this one is also 8 moles. So, as we can see, if I have 8 moles of magnesium, that will also mean I would have 8 moles of hydrogen produced. And what does that mean? Now, we can use the number of moles and molecular mass to actually calculate the answer, because now I actually have 2 values. I actually have my molecular mass from the hydrogen, which is 1 plus 1, and I also have the number of moles. So, I have 8 multiplied by 1 plus 1 gives us 16 grams. And so that is what I've got there as my answer, 16 grams. Let's look at another example. So, sodium hydroxide reacts with chlorine gas to make bleach. This reaction happens when chlorine gas is bubbled through a solution of sodium hydroxide. The balanced symbol equation for the reaction is 2NaOH plus Cl2 gives us NaOCl plus NaCl plus H2O. If we have a solution containing 100 grams of sodium hydroxide, how much chlorine gas do we need to convert it to bleach? What is important in this question? So, having a look at it, this is the equation. This is the question. All of this doesn't matter. In an exam, you need to be able to distinguish between the important information and the not so important information. This is the only bit in the question that actually matters. There is our bleach. Now, we need to find how much of chlorine gas we need to convert it to bleach if we have 100 grams of sodium hydroxide. So, here is my mass. I have 100 grams of sodium hydroxide. It's important to be really clear here that if you are calculating the molecular mass, when you see a 2 in front of it, you must not, under any circumstances, multiply the molecular mass by 2. Because what you're doing there is already you are calculating what 2 moles, what this ratio represents. You're already calculating what that represents. You do not need to multiply the molecular mass by 2. So let's begin. So we have our balanced equation, which is already in a question. The next step, calculate the number of moles of the substance using what we have. So number of moles of substance, what we have, this is the only value in the question that gives us 2 things we can work with. So I can take 100, which is the molecular mass, sorry, the 100 grams, which is the mass of sodium hydroxide that we've got, 40, which is the molecular mass of sodium hydroxide, that's 23 plus 16 plus 1. And after that, we carry that out, and that gives us the number of moles of NaOH, which is 2.5 moles. Now, we have 2.5 moles. We are told that this represents 2.5 moles. If that represents 2.5 moles, and we've got a ratio of, that says a 2, so 2 to 1, and then there's invisible 1 in front of that, and then invisible 1 in front of that, and invisible 1 in front of that. So that means, if that is 2.5 moles, and that is 1, it reacts in a 2 to 1 ratio. That means this number of moles of this must be half that of NaOH. So what we do in order to find this is we do 2.5 moles and we divide it by 2. And 2.5 moles divided by 2 will give us 1.25. That becomes 1.25. And as I say, because of all these are 1 to 1 to 1, all of these will be 1.25, 1.25, 1.25. That's really important for you to remember. We now have 2 values, and we are looking for how much chlorine gas we actually need for it to be converted to bleach. And now we can actually carry out that calculation, because we now have a value for the number of moles which we can use for the chlorine. So that's 1.25 moles of chlorine. So I do 1.25 multiplied by, because I'm using this formula triangle here to calculate the mass, I'm covering up that side, so I'm covering up the mass, so 1.25 multiplied the molecular mass, which is 35.5 multiplied by 2 because it's Cl2, and that will give us 88.75 grams. Very important for you to know that M is always the mass in grams, okay? N is the number of moles, Mr is the relative molecular mass. Now, here's another type of question you might get. When lead dioxide is heated with hydrogen, the following reaction occurs. So this is lead oxide plus hydrogen gives us lead and water. Calculate the mass of hydrogen needed to make 20.7 grams of lead. So we follow the same method. First of all, write the balanced equation. In this case, it's already in the question. Then calculate the number of moles of the substance using what we have. Okay, so what is important in this question? We should know that this is not relevant to the question. What's really important in the question is this. We should also know that we need to find the mass of hydrogen. So this is what we're looking for. And we have as our two values of lead. So we're trying to get we're trying to find out the amount of lead there, and we are told we have 20.7 grams of lead. Okay, so it's the same sort of process. You do 20.7 and you divide it by 207 because we're using that formula triangle there. So the atomic mass of lead is 207. So we do 20.7 grams divided by 207 will give us 0.1 moles. And that is the number of moles of lead I actually have. So we're told that is 0.1. Now, having a look at this equation, let's have a look at the ratios. I can have a look and it shows 1 to 2 to 1 to 2. So I can work with that one. I have been told that if I have 0.1 moles, what I would need to do to find this out, this will be twice of the 0.1 moles. This will be twice that value. So this is going to be 0.2 moles. Just as lead oxide will be 0.1 moles, and this one you'd need to multiply by 2 to your 0.2 moles. We're just trying to match it up with these ratio numbers here. So that tells me now I know the hydrogen actually have this value of 0.2 moles that I can use inside my equation. So I do 0.2 moles and I would multiply it by the molecular mass of hydrogen, which is 1 plus 1, because there are two of them, and it will give me an answer of 0.4 grams. Now the important thing to note there, once again I will remind you, important thing to note there is you do not need to multiply this value, this entire value, by 2 just because it has a 2 in front of the equation, in front of the molecule there. You do not need to do that. You should not do that at all. Let's try one together. So here's our formula triangle. What mass of iodine is produced when 7.1 grams of chlorine reacts with excess potassium iodide? So, the first step you should do, of course, is write your balanced equation. So there is our balanced equation. Okay, so there, in this case, is written in the question. Then you need to calculate the number of moles of the substance using what you have. So I give you an opportunity to do that. Just pause the video. Okay, so calculating the number of moles of the substance using what we have, we can see that we are actually looking for the number of moles of that. So we take the chlorine, 7.1 grams of chlorine, so 7.1 grams, and we divide it by the molecular mass of chlorine, and that gives us 0.1. Now, the next step, use ratios to find out the proportion of moles necessary. So I'm going to give you an opportunity. What I'd like you to do is put your ratio numbers in and then see if you can come up with what number of moles should go under each one. Okay, so now that you've done that, let's see if you got it right. So the ratio, as you can see, is we've got 1, 2, and you've got this 2, 1. Now we are trying to find out the mass of iodine. So we're trying to find out this. So if we've calculated what chlorine is, and that's 0.1 moles, we can see that for every 1 mole of chlorine we'll have, it will give us 1 mole of iodine. So 0.1 mole of chlorine will also give us 0.1 moles of iodine. Then finally, we can input these values into the equation. So we'll take our value there. So this is 0.1 moles. Because as we saw this was 0.1 moles. That's how we knew this is going to be the same. If we were to calculate this, or if we were to find out this will be twice that, so that's 0.2 moles. That's also 0.2 moles. But yeah, this is 0.1 moles. So afterwards you'd use the molecular mass to calculate the answer. So the mass of iodine produced would be 0.1 multiplied by 127 times 2. 127 is the atomic mass of iodine. So you need to multiply that by 2 because it's I2, and then afterwards you multiply it by the number of moles which we actually got, and that will give us a final answer of 25.4 grams. Now it's really important. In this case, we didn't see a lot of numbers that went really long. But if you get to a question which asks you for a lot of digits, or gives you a lot of digits when you are doing a calculation, wait until the end to actually round, because what happens is if you start rounding at the beginning of the question, error can build up and then you can get a completely different answer or slightly different answer for something later in the question, which examiners might not be so lenient on you with. So it's just something you ought to know. Yeah, that's that for this video. So what happened? The genius proved that the emperor to the emperor that just because you can start off with a mass of a particular reactant doesn't mean that all the reactants would end up as that particular product. The genius taught the king how to calculate exactly how much silver could really be obtained from its ore, and that even all the silver could not be obtained from its ore because reactions do not always yield 100%. He decided that his advisors weren't corrupt after all, and all of them were freed. Keep smiling.
For intermission. You don't know what you've been missing. I could see your beauty within, even though it's your decision. Make a change.